Black powder. The original. The explosive that built the modern world, and it's barely an explosive at all. Black powder is a mixture of saltpeter, charcoal, and sulfur, invented by Chinese alchemists around the 9th century who were hunting for an immortality elixir and found gunpowder instead. Here's the key distinction. Black powder doesn't detonate. It deflagrates, which means it burns extremely fast, rather than producing a true shattering shockwave. That's why it pushes a bullet down a barrel or launches a firework instead of pulverizing it. On the relative effectiveness scale, where TNT sits at 1.0, black powder lands around 0.55, weak by modern standards. It's also filthy, leaving heavy smoke and residue that fouls a weapon fast, which is why smokeless powder replaced it. But for roughly 1,000 years, this was the most powerful substance humans could put to work. TNT. The benchmark. Trinitrotoluene is the explosive every other explosive is measured against. When you hear a blast described as equivalent to 10 tons of TNT, that's because TNT is the baseline set at exactly 1.0. Here's what most people get wrong. TNT is not the most powerful explosive. It's the most standard. It was first synthesized in 1863 by German chemist Julius Wilbrand, who made it as a yellow dye. Nobody used it as an explosive for decades because it's so hard to set off. And that's exactly why militaries fell in love with it. TNT is remarkably stable. You can melt it, pour it into a shell, drop it, even set it on fire, and it won't detonate without a dedicated blasting cap. It detonates at around 6,900 meters per second. Reliable, pourable, and almost impossible to set off by accident. The workhorse of military explosives. Dynamite. Nobel's compromise. Before dynamite, the explosive everyone wanted to use was nitroglycerin, and it was killing the people who handled it. Alfred Nobel solved that in 1867 by absorbing the unstable liquid into a stabilizing porous material, taming it into something you could carry, store, and ship without it going off in your hands. That single invention made modern mining, tunneling, and construction possible, and the fortune it generated funded the Nobel Prizes. On the scale, dynamite runs around 1.25 stronger than TNT. Here's where the movies lie to you. A stick of dynamite does not explode because someone shoots it or because the fuse is lit. Modern dynamite needs a blasting cap to detonate. The real danger is old, degraded dynamite that sweats, leaking unstable nitroglycerin to the surface. That stuff is genuinely twitchy. Fresh dynamite, handled properly, is one of the more forgiving explosives ever made. C4, the moldable workhorse. This is the plastic explosive every action movie gets wrong. C4 is built mostly around RDX, blended with a plastic binder that makes it soft and moldable, like pressing putty into a door frame. That moldability is the entire point. On the scale, it sits around 1.34, and it's intensely brisant, meaning it shatters rather than pushes. Here's the part Hollywood can't accept. You cannot set off C4 by shooting it, lighting it, or dropping it. Soldiers in the field have famously burned small pieces of it to heat rations because it just flares up and burns. It only detonates when a blasting cap delivers a sharp shockwave into it. That insane stability is why it's the gold standard for military demolition. You can do almost anything to C4 except the one specific thing required to make it explode. Powerful, predictable, and nearly impossible to trigger by accident. Semtex. The infamous one. Semtex does roughly the same job as C4, but its reputation comes from a much darker place. Developed in 1960s Czechoslovakia, it combines two powerful explosives, RDX and PETN, into a moldable plastic that's stable, durable, and lands around 1.25 to 1.35 on the scale. For years, it had one terrifying property. It was extremely difficult to detect. No strong odor, hard to pick up on early screening equipment. That made it the explosive of choice for terrorism, most notoriously the 1988 Lockerbie bombing. The international response was direct. Manufacturers are now required to add detection, tagans, and odorizing chemicals so it can be found. So when you hear Semtex described as some uniquely devastating super explosive, that's mostly myth. Its performance is comparable to other plastic explosives. Its infamy came from being easy to smuggle, not from being dramatically more powerful than anything else in its class. RDX. the backbone, you've now heard RDX mentioned in C4 and Semtex. And that's the point. RDX is the active ingredient hiding inside a huge portion of the world's military explosives. The name reportedly comes from Research Department explosive. On its own, it's seriously powerful, landing around 1.6 on the scale and detonating at roughly 8,750 meters per second, well above TNT. It was known since the late 1800s, but only mass-produced during World War II, when demand for something stronger than TNT exploded. Here's why you rarely see RDX used by itself. In pure form, it's too sensitive for comfortable handling, so it's almost always blended, coated, or phlegmatized with wax or oil to calm it down. Mix it with a plastic binder, and you get C4. Mix it with PETN, and you get Semtex. Mix it with TNT, and you get composition B. RDX is the engine. The other names are just the chassis. PETN, the sensitive overachiever. PETN is one of the most powerful, common high explosives on Earth, sitting around 1.66 on the scale, even edging out RDX. It detonates at roughly 8,400 meters per second. You'll find it inside detonating cord, the explosive line that links charges together, and inside blasting caps as a booster. Now here's the twist nobody expects. In tiny medical doses, PETN is a heart medication. It relaxes and widens blood vessels, treating chest pain the same mechanism that makes nitroglycerin a heart drug. The same family of molecule that can level a wall can also ease angina. But PETN has a dangerous trait. It's noticeably more sensitive than TNT or RDX, easier to set off, and historically hard to detect. That combination is exactly why it keeps appearing in concealed device plots that make the news. Immense power, real medical value, and a hair-trigger nature, all in one compound. ANFO, cheap and everywhere. Here's a fact that surprises almost everyone. The most widely used explosive on the planet isn't some exotic military compound. It's ANFO, a simple mixture of ammonium nitrate, a common agricultural fertilizer, and fuel oil. The overwhelming majority of explosives used in mining and quarrying worldwide is ANFO because it's cheap, stable, and easy to produce in bulk. On the scale, it's actually weak, around 0.74, below TNT. But it's used by the literal ton, so raw power per kilogram doesn't matter much. Here's the safety feature that doubles as its defining trait. ANFO is so insensitive that it won't reliably detonate on its own. It needs a separate booster charge to set it off, which makes it remarkably safe to handle in an industrial setting. The flip side is grim. Because its ingredients are common industrial materials, it has been misused in large-scale bombings, most notoriously Oklahoma City in 1995. Nitroglycerin, the volatile one. This is the liquid that started it all, and it's terrifying. Discovered in 1847 by Italian chemist Ascanio Sobrero, nitroglycerin was so violently unstable that Sobrero himself was horrified by it and tried to keep it quiet. A sharp knock, friction, or even rough handling can set pure nitroglycerin off. That extreme sensitivity is the whole reason Nobel's Dynamite was revolutionary. It made this monster safe enough to use. On the scale, nitroglycerin runs around 1.5, genuinely powerful. But here's the contradiction that defines it. This deadly liquid is also a life-saving drug. In tiny doses, it dilates blood vessels and treats angina. Factory workers who handled it developed pounding headaches from their own dilated blood vessels, and some suffered chest pains on weekends away from exposure. A phenomenon nicknamed Monday disease, a substance that can kill instantly, prescribed to keep hearts alive. Thermite. Not an explosive. Let's correct a big one. Thermite isn't an explosive at all. It doesn't blast, it doesn't produce a shockwave, and it won't level a building. Thermite is an incendiary, a mixture of a metal powder like aluminum and a metal oxide like iron oxide. Once ignited, it triggers a ferocious reaction that produces molten iron in temperatures around 2,500 degrees Celsius. What it does is burn, not detonate, and that burn is its superpower. Thermite melts straight through steel, which is why it's used legitimately to weld railroad tracks together and used militarily to destroy equipment, weld gun barrels shut, or wreck artillery so the enemy can't recover it. Games and movies treat it like a bomb. In reality, it's a blinding, downward-flowing burn that you cannot stomp out because the reaction carries its own oxygen. Dump it in water, and it keeps going. Slow, brutal, and unstoppable once lit. By far, I've now covered 10. Which one genuinely surprised you the most? The heart medication explosives, or the fact that thermite isn't an explosive at all? Drop it in the comments. I'm curious which one breaks your brain. Napalm, fire that sticks. Napalm isn't a detonating explosive either. It's an incendiary, and its genius is in the chemistry of stickiness. Plain gasoline burns too fast and splashes off surfaces. Napalm uses a thickening agent to turn that gasoline into a gel that clings to whatever it touches and burns long and hot. It was developed at Harvard in 1942, and the name itself comes from the thickeners originally used to make it. Why gel the fuel? Because fire that sticks to a target and keeps burning is vastly more destructive than fire that flashes and disperses. It burns in the range of 800 to 1,200 degrees Celsius, consumes oxygen, and is extremely difficult to remove once it adheres. It saw heavy use in World War II and Vietnam. Because of its horrific effects, its use against civilian populations is heavily restricted under international convention. Devastating, simple, and almost impossible to escape once it touches you. White phosphorus burns in air. White phosphorus is so reactive it ignites on contact with air all by itself. No spark, no fuse. Expose it to oxygen and it bursts into flame, burning intensely and throwing off a thick white smoke. Militaries use it for exactly that smoke, deploying it to screen movements and mark targets, as well as for its incendiary effect. Here's what makes it so feared. It's extraordinarily hard to put out. Smother the flame, and the moment it touches air again, it reignites. On flesh, it produces deep, severe burns that are notoriously difficult to treat. Soldiers nicknamed it Willie Pete. Like napalm, its use in populated areas is restricted under international law, precisely because the burns it causes are so severe and so hard to stop. A substance that needs nothing but air to become a weapon, and refuses to be extinguished by anything that lets air back in. Composition B, the blend. Composition B is what you get when engineers stop looking for one perfect explosive and start mixing. It combines RDX for raw power with TNT for pourability, plus a small amount of wax to calm the mixture down. The result lands around 1.33 on the scale, stronger than TNT alone. Here's the practical problem it solves. RDX is powerful but difficult to cast into a shell. TNT is easy to melt and pour but weaker. Blend them, and you get the best of both. A powerful explosive you can still melt pour straight into bombs, artillery shells, and warheads. That made Composition B one of the most important military fillers of the 20th century. There's no exotic story here, no terrifying instability. It's a smart compromise, the explosive equivalent of mixing two metals into an alloy to get properties neither one has on its own. Practical engineering, not chemistry magic. Picric acid, the predecessor. Before TNT took over, this was the explosive filling the world's artillery shells. Picric acid is more powerful than TNT and was adopted by major militaries around the turn of the 20th century under names like lyddite and melanite. On paper, it was a clear upgrade over black powder shells. But in practice, problems appeared fast. Picric acid is corrosive. It reacts with the metal of the shell casing to form metal compounds called picrits, and those picrits are dangerously sensitive, capable of detonating from a simple bump. So your ammunition slowly turned itself into a hair trigger hazard just sitting in storage. It also stained everything it touched a stubborn yellow. When TNT arrived, offering similar performance with none of the corrosion or sensitivity headaches, militaries dropped picric acid almost overnight. A powerful explosive undone not by its blast, but by its chemistry quietly sabotaging the weapon around it. Octanitrocubane, the lab unicorn. We'll end with the most exotic one, an explosive that exists more in theory than in reality. Octanitrocubane is a laboratory-engineered molecule built on cubane, a bizarre cube-shaped carbon structure, saturated with nitro groups to pack in as much explosive energy as physically possible. On paper, the numbers are staggering. It's predicted to be one of the most powerful non-nuclear explosives ever conceived, with performance estimated well beyond TNT, RDX, or PETN. But in practice, you'll never see it on a battlefield. It was only first synthesized around the year 2000 after enormous effort, and it can only be made in tiny laboratory quantities through an extraordinarily difficult and expensive process. There's no way to produce it at any meaningful scale, so it stands as a chemistry milestone, a proof of what's theoretically achievable rather than a usable weapon. The most powerful explosive on this list, and the one no military will ever fire,